All right, here she is, my homemade wood boiler. I'm gonna go through some tips that hopefully will help you because I am not a welder, I am not a plumber, and there was a big learning curve with this. So first of all, I picked up this wood stove for a couple $100. I made sure it was big and chunky. I used a flux core welder to do this. I used predominantly 0.0035 flux wire. On that note, I tried Lincoln. I had some Mastercraft lying around, and both of those were smoke and spatter. Like, it was insane. And then I found this random stuff on Amazon that was like spatter free, and it was a game changer. I only discovered it on the last side box, on the small one. Now, I don't know much about it. I thought Lincoln would have been the Cadillac, but this stuff, when I had it, it's like right here, came for 3 rolls. It was $20 each, but it had like 5,000 reviews and 4.5 stars. This is the stuff I would use because the last box, I only had like 3 holes to do when I did this. So this isn't like a throw it together thing. This was quite the project. Initially, I used thinner steel. I think it was 1/8 steel to try and make these boxes, and even though I tried to use low temperature and a bunch of stuff, the box just warped like crazy. So I made the boxes first and then I put them onto the wood stove. If I was gonna do this again, I would like triple bead the inside. What I did was I shaved a little bit of the edge off the steel. So let's say this is my steel. What I did was I would take an angle grinder that was going to actually you should do it for both sides, but grind the top of this. This is the thin stuff that I use, by the way. Grind the edge and create a bit of a valley so that when it goes up against the box, you have more of a gap to fill. And that made a huge difference. So not 1/4 inch, it was just too thin. And on top of that, hopefully this will last a while. That was my initial experience. So on that note, when it comes to the pipes that come out from each one, what I'm gonna do is I'm gonna do PEX pipe and fittings. And the spatter made a really big nightmare out of these threads. The spatter got onto here and then I started having issues. So I would put the brass fitting onto it first while I was doing the welding. On the note of these pipes, if I was going to do this again, I would not do them coming out the side, which I thought was pretty clever. And here, I have another one. I would not put it here. I would put it here. The reason being is that these pipes, I did not weld them very well. And then I had to try and re-weld them in place. And especially this tiny gap in here became a real fucking nightmare. Pardon my language. And it always leaked. Like I welded each end. I did everything right. Just making that clearance really sucked. And so I would do it off the side. It wouldn't really make a difference other than aesthetics. No, I just wouldn't do it. This is 2 inches wide and this is a 1-inch pipe. So that left me very little room. And as you can tell, I didn't really get it center. So that left me a whole bunch of nightmares there. So these pipes that we connect all the boxes to, I would do it on the side. When I was doing these, I would make welding tabs, round them off so you don't get stabbed in the leg. Because yeah, that happened to me a couple times. So anyway, so pre-make the boxes. And then I water tested them to see how much they leaked. I think that was a waste of time. Just weld it and take it. And then you can, when you do the vacuum test or pressure test, what you can do is you can re-weld them then. Just weld it the best you can and then go. Unless you have like some heinous hole, patch it up. So make the box, put it on there, weld her up, put the pipes on the top or on the sides, like don't put them where I put them. And then when I was doing this, you got to tack them in place. This may be obvious to welders, but what happens is the steel warps under heat. As an example, I got too excited. When I did this box, I tacked just a few tacks and then I did the whole top bead of this. And then when I was done, I noticed that this thing was like way out here. So to overcome that a little bit, yes, tack them. But what I also did was I ratchet strapped with like a 1,500 pound ratchet strap around the wood stove to keep this flat against here to prevent that from happening. And then what I would do is, I had lots of tacks. I would do the top, I would do the bottom, and then I'd let go of the ratchet strap so I could do the sides. Didn't have any popped welds. So the other thing I would do is, I'm gonna show it from this side. See how I tried to maximize my surface area on the side here? That wound up becoming a nightmare on a few examples. Here would be a good example. Trying to get in here with the grinder was really difficult. So I would have set that back. Yeah, you lose a little bit of heat pickup, but what I had to do is I had to get a 7-inch disc instead of the standard 5-inch disc in order to get into some spots. And on a 5-inch grinder, 4.5-inch grinder, you're very much paying attention or else accidents are going to happen. So the other thing I did was I lifted this thing up on a box to make this so I wasn't welding way below. This is the box it actually sits on in the greenhouse. And so that way I'm stoking wood while standing up instead of hunching over each time. So yeah, 7-inch grinder, 7-inch grinding disc was pretty valuable. I wouldn't need that. That was like needed to get into spots like here where I couldn't quite make that clearance. And the other thing was I had to be super careful as to not hit the threads back here. That was another issue that happened. Another reason to put these pipes down here. So these may, again, seem like obvious things to a welder. I am not a welder. So make the boxes smaller than you think, and think about the clearance on stuff like these hinges were an example. In here was an example. Just think about how you're going to get in there to clean up the welds afterwards and redo them. So then I get the boxes welded up, and what happens is I went to a plumbing shop, and I got one of these. So basically it's a bike valve adapter and a gauge. This one goes all the way up to 60, but I only put 10 PSI on this because this is not a sealed system that I am doing. It's going to be like open into a barrel. So it's going to be under like 1-2 PSI. So doing a 10 PSI test really showed where any of my holes were. And so what would happen is I would do, let's go back to this box. I would do this box, I would cap that. And then the other reason not to put these pipes, like where I put them, is that then getting stuff on to do the pressure test really sucked. Like I couldn't turn something here, and when I go to put the brass on, it's going to be a bit of a nightmare and slow and steady. But then I had to like make an adapter so that then I could put that other pressure gauge on there. If this was on the side, it just would have been so much easier to do this. What you don't see on the inside is that in this case, I have a pipe here. Inside of here was some of that thinner steel that I had lying around. I created a fin, a baffle, whatever you want to call it, that went here to here. That's just tacked in place. It didn't have to be super welded. And what that does is ensures that the water flows down here and comes around instead of the water just being like, poo, straight down. So anytime, however you decide to design your box, you can create fins in there to divert it. If you want to be super elaborate, you could probably like fin a whole bunch of this to like maximize efficiency. But I figured with as much surface area, like this is like 12 by 12. The one on the back is like 12 by 17. That's tons of surface area. Like I'm soaking up all the heat that I can get. So I get the box on there. I think that I've done a good welding job. And then I do the vacuum test. Sorry, I keep saying vacuum, but pressure test. And then I eat some humble pie because turns out I suck until I got that good wire. And then all of a sudden, like the last box I did was on the other side, this one, and I only had 3 holes. And it just made a massive difference not having smoke in my face and not being able to see where my weld was. So pressure test it, and then I would take a spray bottle with a little bit of soapy water, spray it, find the spots, then use an air compressor to clean up those areas. Sometimes I'd grind it. Sometimes I was able to just patch the hole where it was. That's why if we get any close-ups, you'll see just some ugly welds that I'm like, not going to grind it. It plugged the hole, done. There's no aesthetics here for me. So, like you'll see where these paint line marks are, that's wherever holes were, and then re-weld it, So, one box at a time. Now I'm done all the boxes. They are sealed. And then the last thing I'm going to share, and I'm pretty sure the welders are going to cringe about this, is it's going to serve 2 purposes. So when I pressure test this, as all 4 vessels. Make sure that I don't have any leaks left, because once I fill this with water, where some of the pipes are, it's not going to drain. And so that's the other thing you might want to think about, is trying to drain somewhere. But if not, that's why I'm pressure testing again, all 4, 10 psi. And then what I'm going to do is I'm going to use something called sodium silicate. It's actually used for sealing concrete, and it's like a main ingredient. If you've ever had a leaky radiator, it's the main ingredient in that. So what I'm going to do is I'm going to run that through the system to patch any tiny holes that come through. And on welds, like we'll get up here, what'll happen is, let's say right here, what'll happen is I'll start seeing a bit of a leak, like a tiny one, and then I'll hit it with heat, and then what that does is it seals it up. This water is never going to get hotter than 80 degrees Celsius. I don't know what that is in Fahrenheit. So that's going to seal any micro holes that are in there. What it will also do is it's going to coat the steel on the inside to prevent corrosion. And so I learned about this. It's used in different applications. It's used inside of kilns, so where it's way hotter. So basically it's a salt covering, which sounds weird. It'll harden, and then it won't be soluble again. It's like water when you buy it. And then I'll pump that through. I'm going to fire this up outside. And then what I'll do is I'm going to go along with a propane torch, and because the PEX fittings will be on here. And what'll happen is I'll go along the edges where I start seeing water, and I'll hit it with the torch, and then do that. Hopefully, I don't know what the curing temperature is of sodium silicate, but hopefully just the water gets hot enough to actually seal it. So that's how I'm going to do kind of the final seal on it, which is a huge relief. And the corrosion prevention will also be big. Once this is all done, then I will paint the outside. But that is how I am doing my own homemade wood boiler. Feel free to ask any questions. This is Mateus from Cobble Hill Gardens. I'm putting this inside of a greenhouse. So my tolerances are a little more loose than in, let's say, I had it here inside the shop. And I think that's all I have to share. 10 psi felt good. Put the pipes on the side. Try and get good wire that doesn't spatter. If I remember, I'm going to put it in the link below, the type. And then, yeah, I will do a follow-up video about how hot the water actually gets.